Now, the ionosphere itself is an area situated very, very high above the Earth, as I've said, but it's also a very important area for our immediate environment. This particular layer can be visualized as a bubble surrounding the planet. This bubble of energized particles keep particle streams that would be dangerous to human health from entering our immediate environment, such as X-rays, cosmic rays, and various radiations coming from the sun. So it acts as more or less a shield, a natural shield, to protect the planet. Without it, life would be impossible here. And this is the area that the military intends to, as they say, perturb, as we say, disturb, deliberately for weapons effects. Now, what's important and what's very different about this technology is the military will cite the idea that these ionospheric heaters are located in many, many places around the planet. However, what is located around the planet do not have the power levels that this particular transmitter has. What happens in the energy transfer, starting with the ideally it would be natural gas, currently it's diesel power generators on site, generate electricity. That electricity then runs through the apparatus on the ground, the ionospheric heater, and through a principle called antenna gain, you get an effective radiated power in the upward level with this system of 1 billion watts of effective radiated power. Now that's the power coming off the ground. If we go back to this image of focusing energy again for just one moment. So what we're talking about in terms of energy, it's not the energy going into the systems or into the antenna arrays. And it's not the energy coming directly off the antenna arrays at the ground level. What we're concerned about is the amount of energy at the point in which we're trying to create effects, which is the ionosphere. And as you can see from this characterization, the old technology spread that energy out. It was very, very low-density energy, whereas the new technology, the technologies developed by Bernard Eastlund, focused that energy into a very narrow beam. This is the rating that is most appropriate, most important in describing this particular technology. In terms of talking about where this energy goes, what happens with this energy in terms of the overall project. When the military first unveiled this project back in 1991, what they were talking about was the fact that, hey, this was unique because we had this unique focusing and steering capability different from any ionospheric heater in the world that would give us incredibly greater power potentials. More than that, they also compared to other systems operating around the world. There are 5 of these transmitters in the former Soviet Union. There's also a system called ISICAT in Europe, and there's a very large transmitter in northern Norway. The transmitter in Norway has 1 billion watts of effective radiated power at the ground, but using the old configuration, spreading energy out. The new technology is, again, the very big breakthrough for Bernard Eastlund, and also for Arco Power Technologies. Now, what's also unique when you think about energy being transferred to the ionosphere to create the varying effects, if we look at that image and we talk again about the idea of a bubble around the planet, this is another image of Bernard Eastlund's showing very clearly what can happen if you can energize this area. What he shows in energizing this is this cyclotron resonance effect that creates this bubble. The amount of energy required to create a global effect is quite large. In fact, when Bernard Eastlund first envisioned this system, the amount of energy that he visualized coming off of an antenna field was somewhere on the order of 100 million watts. And we're going to come back to that number as we go through the presentation today, because it's a very important issue in terms of what this project could entail. One of the things that when we go through the discussion of the applications of the technology, we'll talk a little bit, too, about the power levels necessary to create these varying effects. In terms of the overall program itself by the military has maintained throughout this project that it has nothing to do with Bernard Eastlund, which is in and of itself probably the biggest departure from the truth. When you look at the fact pattern, the paper trail on the project, which we're going to present in a few moments, you'll see how Bernard Eastlund's work really does come into play on this project. What Bernard envisioned was a single antenna field of very large size. In fact, the size that he envisioned initially ran 20 kilometers by 20 kilometers square. huge by anyone's standards. HAARP is, of course, much smaller than that at this stage of its development. But as we go into the next slide to look at the overall effects, a couple things that we can first take a quick look at is if you look at the owner of this patent, this is APTI Incorporated, which is Arco Power Technologies, Inc., which is the subsidiary of Arco, Atlantic Richfield. In this particular patent, not by Bernard, but one built upon Bernard Eason's ideas, at the lower portion of the screen, in this section under U.S. Patents References Cited, this is where you're required to show the information as to where it came from or what built your idea. And when you look at the other portion of the screen, what was this particular idea building? Well, it was based in part on a particle beam weapon system, on backscattering technologies, which is radar technology we'll talk about shortly, and also space-based ballistic missile defense systems, or Star Wars systems. When you look at the next slide, which shows sort of the application of what this specific weapon application is, I think we can see quite clearly what we're talking about. In this case, we have graphically depicted at the bottom of the screen an antenna. In this case, it's a single antenna, but it's strictly for graphic purposes. What it does is it sends energy up, creates an energy field around these objects in space, and then using a gamma ray detector, which is actually one of the inventions that are held by APTI in a packet of inventions, can determine which of those objects are actually carrying nuclear payloads and which are not. Now, why is that important? When you think about an attack, which the military envisioned for a couple of decades, what they envision happening is 100,000 incoming objects. And of those 100,000 incoming objects, perhaps 100, maybe 200, maybe as many as 1,000 would actually carry nuclear payloads. In order to isolate the target, you have to be able to discriminate which are decoys and which actually are genuine threats, because there's no way that we have the capability of, with certainty, taking out all of those targets. So the situation is, in terms of the military, has been, how do you distinguish? What can we do? In this particular technological application, what you have is a system that can discriminate. In other words, reducing the targets to those that are really targets of interest. And this is done with a transmitter such as HAARP being able to generate power levels of sufficient quantity and size. Now, it's not the only patent. As I said, there are 12 patents associated with this project. 3 were Bernard Eason's. The others were based in large part on his work. But all of those other patents that were based on his work required one unique feature. They required a focusing capability. This was the key element in Bernard's work. In fact, the key element leading to his patent. The slide that we had showed earlier showing that energy focus is really important in terms of application. And looking at this next slide, what we also see here is the idea of creating an ionized clouds above the Earth. Now, what this is used for is reflecting radio frequency energy for over-the-horizon radar applications. And you can see here also it is an APTI, Arco Power Technologies patents, and you can see in the references cited again, this work is based in part on Bernard Eason's previous patents, again showing a connection and a trail. In terms of the next slide, it shows sort of the application of this and what it looks like graphically. And this is important in terms of describing the technology. When you look at this particular aspect of the project and what it does, in this view, you can see what they're using here again graphically is they're creating a plasma layer in the ionosphere. And this can be visualized as a layer of energy. And what it is used for is reflecting energy from another transmitter over the horizon, and you can see the horizon of the Earth, and to look over the horizon to see what might be incoming. And in this case, it's picking up an airplane over the horizon. Now, as this diagram indicates, it requires 2 transmitters. In fact, there are 2 in Alaska. There's a smaller transmitter called High Pass, which is located just outside of Fairbanks, about 250 miles from the HAARP facility. What's also unique is for this application, which can be called over-the-horizon radar, the location of the current HAARP facility is the old